a direct quote from Dr. Strangelove, if you're familiar with it. So I'm going to talk about Janus today, which is a WebRTC gateway. So I'll try and explain a bit what this means during the course of this presentation, and I'll also try to address the whatever happens on the SIPS side in particular, because as we'll see, Janus is pretty much, let's say, as general purpose as possible. At least we conceived it that way, but we also kept, of course, SIP1 in mind, because that's what we needed as well. And this is a very quick overview of what I'm going to talk about. So first, some context on WebRTC, even though it's probably not needed because we've seen a presentation on WebRTC yesterday. I'll also try to describe a bit which were our requirements at the time and what led eventually us to work on Janus and to build it the way it is right now. And so I'll go a bit through the way the Janus architecture is conceived. I'll say a few words on SIP specifically, and I'll also explain a bit what people are doing right now with Janus and where we're headed to. So before starting, a few words on us. I'm Lorenzo, Miniero, by the way. I forgot to introduce myself. And I'm one of the co-founders of Mitico, or Miteco, however you want to call it, a company that is based in Napoli, Naples, which looks pretty much like this. I've been there, and our office is, I guess, a tiny pixel somewhere over the left. And we were born from the academia, because I took my PhD over there. Some of my colleagues did too, and our professor is also one of the co-founders of the company. And we worked a lot on real-time multimedia applications in general. We started on multimedia conferencing from a strong standardization perspective, because we were very involved in the ITF since the beginning of the XCOM working group in particular, if you're familiar with it. And then we widened the scope as much as possible to try to cover as many multimedia applications, real-time multimedia applications as possible. And WebRTC definitely helped us there, and I'll also explain why in a few slides. And if you're wondering what we do for a living, we basically do a lot of consulting based on Janus and other things. We try, of course, to provide also commercial support and licenses. We do the streaming of live events pretty much like this one as well, and a few examples are the ITF, a couple of editions of the ACM, SIGCOM conference. We're going to stream SIGCOM again this year in Brazil, and also some products that we developed that we basically sell subscriptions for. So before moving on, some few words about WebRTC in general, if you're not familiar with it. And it's basically a way to allow browsers to implement real-time multimedia interactive applications within the browser itself with no need of any specific plugin. Because you may remember the times whenever you wanted to do a video conference or something like this in the browser, you had to rely on stuff like Adobe, Silverlight, Java Appets, or things like that. You basically needed a plugin to be available in your browser or whatever you use to navigate, and that basically took care of that part, which was a nightmare for everybody, for users, for people who had to actually work on these plugins, because they had to take in mind the cross-platform, cross-device, cross-system, because with the advent of mobile platforms, plugins became even more a nightmare and so on. So they were really hard to maintain. They even became security issues, as we've known lately with Adobe, with Adobe Flash, for instance, which led the two main standardization bodies, the ITF, the Internet Engineering Task Force, and the W3C, the World Wide Web Consortium, to try and start working together on a solution that was standard and actually integrated within the browser itself, which is what eventually led to two different actually standardization efforts, the RTC Web in the ITF and the WebRTC effort in the W3C. And they basically, let's say, handle the two different parts of the specification in a complementary way. So the ITF takes care of whatever happens, whatever travels over the wire, so the protocols, the formats that are going to be used and things like that. And everything that is instead happening, let's say, on a user interaction kind of approach, so whatever needs changes to the HTML, JavaScript specification and things like this, is done by the W3C instead. And together they basically provide you with the so-called WebRTC specification in general. And the way it works is not that different from SIP in general. In this case, we see a very simple triangle, let's say a simplified version of the famous SIP trapezoid, where we have two separate users that want to make a communication with each other, that want to talk with each other via WebRTC. They basically refer to the same signaling server, which is typically a web page. Let's say we are both on Facebook and we want to talk to each other. We're both actually talking to the Facebook web page through, let's say, some some signaling messages, it may be dynamic requests via Ajax or WebSockets or whatever. We exchange some kind of information, which again is pretty much similar to SIP in general, because as we'll see later, SDP is still involved. This eventually leads to the setup of the actual multimedia communication, which is what we see over here. So while the setup and the negotiation and negotiation mechanism is, let's say, travels across this server, the actual multimedia exchange happens is peer-to-peer. So the two browsers are actually going to exchange media between themselves, and the web server is not involved anymore. And for this, again, the WebRTC specification derives a lot from the existing standards, like the whatever happened within the ITS or SDP, RTP, and things like that. We still have RTP in the background in WebRTC, but it's, let's say, powered up because it's always secure by default. You cannot have plain RTP in WebRTC. And more specifically, its security is even more enforced by means of DTLS SRTP. So no secure restriction, SDS, and things like that. And besides, the ICE specification is also mandatory to implement, so that you have to take care of not traversal and all those kind of things within the WebRTC specification. So you cannot just rely, for instance, on the connectivity information and SDP on the course that is specified in the M line and things like that. You have to rely on ICE for that. And the nice thing about WebRTC, and especially from our point of view, was that we've seen this example where two people are communicating with each other, but this doesn't mean that both of them must actually be real persons. One of them can actually be an application. In this case, it could be, for instance, a WebRTC gateway of some sort, where a WebRTC gateway can be abstracted in, let's say, two separate core functions. One of them being handling the negotiation and signaling part somehow, and another component handling the media process in another way. Because if we think, for instance, about that WebRTC user wanting to call a SIP endpoint on the right that you see over there, maybe a SIP endpoint that only talks plain RTP, doesn't support security and things like that, only talks SIP and so on. You may have to, of course, involve some kind of gatewaying functionality for both the signaling and possibly also the negotiation part, because the WebRTC SDP may contain a lot of stuff that the SIP endpoints are not aware of and do not support for some reason. And at the same time, you may have to take into account also the managing of the media itself. So even if, let's say, the codecs are all compliant, so you do not have to do transcoding and things like that, you probably still have to take care of the ICE process and the DTLS security exchange yourself in order to make available on the SIP end something that is much easier to digest and to handle, so that you are, let's say, as backwards compatible as possible without having to worry too much about updating your own stuff in the backend. And you can, let's say, generalize this kind of approach to several different technologies. I made the example of SIP, but you may also involve, let's say, I want to access an RTSP stream because I have a security camera somewhere, I want to access via WebRTC, I want to talk to an RTMP or Silverlight component in the backend to publish flash media, or whatever other technology in the backend that may need to be transcoding. In principle, everything that is actually existing already in the network can somehow, let's say, with a bit of effort, translate it to and from a WebRTC to the WebRTC specification, so that you can actually have these two different worlds interact with each other. And you may wonder actually if there is a need at all for a gateway, because of course, if you actually care about, let's say, leveraging existing infrastructures, like for instance, an existing SIP infrastructure, as is your case, you're probably interested in having some kind of component like this. Gateways also helps, let's say, fixing things in between implementations, because WebRTC is a living effort. Different people are working on different specifications, and so sometimes they do not talk to each other. Having a gateway helps them communicate with each other no matter what. It also helps leveraging full meshes, because anytime you have a component in the middle, it helps, let's say, avoid the need of having a full mesh communication whenever you want to do, let's say, a media conference and so on, via plain WebRTC, which is just plainly peer-to-peer. And otherwise, if all of those things are not relevant to you, and maybe you do not want to go beyond the interaction among the few users, you do not need an infrastructure in place to take care of that, or maybe you do not care at all about legacy stuff, pre-existing stuff, and so on, then you probably do not need it. Anyway, this is just a very, very quick overview. If you want to learn more, this is a blog post that I wrote a couple of years ago on the WebRTC Hacks blog, so you can just read there if you're interested in more details. So all of these were basically requirements for us. So we were interested in in implementing some sort of gateway that would do something like this. And of course, we understood immediately that writing a gateway from scratch is really a heavy task, because you need to take care of the implementation of the whole WebRTC protocol suite, which is far from trivial, because this is a slide that summarizes basically all the requirements of the WebRTC specification, so everything that a WebRTC compliant endpoint must implement. And you can see there are a lot of different things that you need to take care of, a lot of protocols, some of which you can reuse because they are the same things that are used, for instance, in VoIP in general, but a lot of things actually are not, and so you have to take care of them, which is why I put the launch picture over there, because this slide usually takes a big shout out to people when they see it the first time. And so, and of course, we also wanted these components to also be able to talk to legacy components, as in pre-existing components at the same time in the backend. So we do not only have to worry about implementing the WebRTC suite, which is complex by itself, but we also want to talk to one, two more different words in the backend and so on. We may wonder about getting statistics works and so on. Reachability may also be an issue for some reason, and this means that there are, of course, different technologies involved, different requirements and so on that you have to take into account. And besides, we also wanted it to be as programmable as possible, which means that we did not want a component that was, let's say, very monolithic with a few very specific functions in it, but we wanted something that we could extend later on, because of course right now we have some, let's say, scenarios and use cases in mind that we wanted to tackle since day one, but of course this doesn't mean that these are all the scenarios that we wanted to tackle. Each day we face new challenges, new requirements and so on, and we didn't want to write something exactly from scratch again or manipulate something from scratch again just to cover this new additional scenario, which means that we wanted something that could be programmable and that would allow us to manage the flows and use this in a dynamic way. And we took the media control specification as, let's say, as an inspiration for this. Media control, if you're not familiar with it, is a standard specification defined within the ITF to standardize basically the communication between application servers and media servers to allow you to implement complex applications like IVR, conferencing applications, and so on, all in a dynamic fashion using dynamic control packages basically. And we followed pretty much the same approach. And now coming to Janus itself, Janus is the name that we chose for the component that we implemented that had all those requirements in mind. And for a very simple reason. It's basically mostly because I'm a nerd that loves all that classic stuff from the past. But in general, Janus was the Roman god that basically always had two faces, looking at one at the past and one at the future in general, which incidentally is why January is called like that, for instance, because it always looks at the year that has just ended and then looks at the year that is coming at the same time. And this looked like the perfect name for our project as well, because we were actually writing a component that could actually talk WebRTC on one end and something else on the other end. Which means that in our view, Janus was always looking at, let's say, the past in quotes, so legacy technology, something that existed already, and then at another phase, always looking at what for us is the future, which is WebRTC. And the nice thing about this is that it's completely open source. You can see some links over there. This is the GitHub repository where you can find our Janus gateway, so you can just download it and play with it as much as you want. If you want to just use it for a few online demos just to see what it can do quickly, you can just jump to where we have the demos and documentations over there, and we also have an active community as a Google group there. So just feel free to play with this a bit and let us know what you think about it. So coming to the architecture, as I was saying, we derived, let's say, a bit the what I call the media control approach, which means that we wanted some kind of a modular approach, and this means that we wanted the core, so the Janus core, to actually implement everything that was related to the WebRTC stack, and we've seen what this means, so implementing all those protocols and so on. And this means that the Janus core takes care of whatever is related to WebRTC itself, so it takes care of JZAP, SDP, ICE, DTLS, data channels, all those kind of things. And then we have different models that can actually implement some, let's say, things that can actually be extended and handled in a different way. One of those being the models for actually communicating with Janus, because in principle you can communicate, at the moment you can communicate with Janus via HTTP, WebSockets, RabbitMQ, and in a pull request also via Unix sockets. But then the actual implementation logic, so whatever you want to do with the media that is being negotiated with Janus, is actually completely delegated to server-side plugins, which means that the core doesn't even know what we are going to do with the media. And just to make a simple example, we have some proof of concept implementations of some plugins. So we have, for instance, a plugin that does a simple echo text, which means that whenever you attach, whenever you call Janus and attach your peer connection, basically your media channel to the echo text, you are going to just have your media be bounced back. So basically, a very simple logic being enforced on the application, on the stream. We have the streaming plugin that takes care of live events, so let's say the streaming of something that was not originating WebRTC, but that can then be broadcasted to WebRTC users. The video room plugin does basically video conferencing features, or more in general, a selective forwarding unit. So you have somebody broadcasting, sending one stream via WebRTC, and then you can broadcast the stream to a lot of people at the same time, which means that you can use that for web conferencing, for webinars, for just plain routing of media wherever you want it to go. And then, of course, we also have a SIP gateway plugin, which implements all the SIP logic and allows us to use SIP within Janus itself. And again, the core does not know anything about this. The core just takes care of the WebRTC stuff and then allows the users to communicate with plugins, and then it's the plugins that decide what to do with this media. So if these plugins want this media then to be broadcasted to another user within Janus, through another user that is attached to the same plugin via the Janus core, then it can do so, and the Janus core will make sure that whatever media is being broadcasted or forwarded there, it ends up to the via WebRTC to the user that is meant to receive that kind of media, which is, in our opinion, a quite powerful mechanism, because it allows us to not care at all about what happens in the back end. We just have to, let's say, separate the responsibilities. The Janus core just needs to take care of WebRTC, which is complex enough, and it doesn't have to worry about anything else. So if you want a new plugin that does something new that is not covered there, you just write a new plugin without rewriting the Janus core. You just write a new plugin that just does exactly what you need. And just to give you an idea of how this extensible architecture works, this is an example where we have, let's say, a browser that is talking to the Janus core via HTTP, it could be WebSockets or other things, as we mentioned. We have our own JSON-based protocol in order to communicate with Janus so that we can control Janus, talk to the plugins in the backend, and so on. And in this example, we have two different peer connections, which means two different media channels created between the browser and the Janus core. And in this specific example, the two peer connections are actually handled by two separate plugins. And this could be, for instance, the SIP plugin as the red box that we see over there. And in fact, we see that, for instance, there's a legacy protocol being involved in the arrow on the right. And instead, the other peer connection may be, for instance, the video room plugin, because you want to do video conferencing via WebRTC, playing via WebRTC, and maybe audio conferencing via SIP, just to make a very simple example. And as you can see in the example there, you can assume that between the browser and the core, everything is WebRTC based. So as we said, there's VTLS, there's ICE, there's SRTP, and so on, all the complex stuff that WebRTC is about. The plugins do not know anything about that. So the plugins only see plain RTP coming in and out. So they can basically manipulate the media pretty much as they want. They may want to record it, they may want to forward it to something else. They may want it to just route it within Janus and get it somewhere else and so on. It doesn't matter. The plugin is completely free to do whatever it wants with it. And it's plain RTP. As soon as this plain RTP gets back to the core and needs to reach a WebRTC user, this is wrapped again in all the WebRTC layers so that it's actually made WebRTC compliant. So the plugin does not need to worry about the WebRTC details, and the core does not need to worry about anything that is happening at the application level, because everything is handled your own way. And this, of course, means that we also had to have, let's say, an extensible mechanism also for the messaging, for allowing the users that were talking to Janus and the plugins themselves to somehow talk to each other. And for this, of course, we have our own Janus API, which is JSON-based. And in principle, of course, Janus has its own API to set up sessions and so on, but whenever you want to talk to a plugin, then the Janus API basically becomes as a transport, so an application level transport. So you send and receive messages to the plugins and using the Janus API as a transport, so that the plugins only see basically the messages that you send to them, which means that each plugin can implement its own JSON-based API, which can be completely different from what other plugins implemented and can be completely new. The core doesn't worry about it because it knows it's something that only you and the user are going to exchange with each other, which is also quite nice, because it means that any new plugin implementing new functionality can just talk its own language with the users. You can implement your own requests and response, your own events, anything that you want you can do, basically. And we did it like this for several reasons. One of those being the extensibility in the first place, as I mentioned. But another interesting example, for instance, the conferencing plugin, the C plugin, and so on, we did not mean those plugins to actually be seen as full-fledged applications. So they do not have to be seen as self-contained applications that do only this. You can actually see them as bricks that can be used to build a much more complex apps. And I'll make some examples later on. So you just, let's say, you can actually combine different plugins in the same web application, so that the user, let's say, sees a lot of media coming in and going out, but doesn't necessarily need to know that there are different plugins and in the media. It just sees audio and video coming in and out and so on, and in order to implement a new kind of application that is actually much more complex than just using the single plugin that we see over there. And these are just a few examples that could be implemented, some of which we are using actually regularly in our own products. And one of these may be, let's say, a multimedia conference, a WebRTC multimedia conference that still needs to have PSTN support, because, for instance, we want people with phone being able to communicate with the people on the WebRTC side of things. And for this, we can actually do this, for instance, by combining the video room plugin to handle everything that is video related. So you use the video room plugin to broadcast the participants' video, the screen being shared, and anything like that. And then for the audio part, you delegate everything to the C plugin. So maybe you have a conference bridge somewhere that you know is reliable. You have PSTN configured, PSTN access configured there, and so on. So you just have your WebRTC users use the C plugin in order to reach that conference bridge, and you're sure that whatever happens there on the audio side is going to be available to all the users that are going to be using plain C for PSTN access and so on, and they are going to be able to interact with WebRTC users as well. At the same time, if you want to limit it to only WebRTC, you can also, let's say, envisage a scenario where you have a webinar with a question and answers, pretty much as we're doing right now, but on the web, where, again, you may use the video room plugin for, let's say, screen sharing and sending the speaker and so on, but maybe rely on the audio bridge plugin for the question part. And the audio bridge plugin is basically a completely WebRTC-based plugin that resides in Janus itself that can do audio mixing, so that you can basically avoid going to a conference bridge elsewhere. You just do everything on WebRTC, and you do mixing over there. It may help. Or otherwise, you can just rely on the video room plugin to do audio as well. In that case, you have to, of course, to broadcast audio at the same time, so there's no mixing involved. You may want to do something like a social TV application, where you may use the streaming plugin for the TV channel. So maybe the TV source is coming from an external proprietary application that is not WebRTC compliant, is not RTP compliant, and you may be capturing it with tools like FFmpeg or GStream or whatever you want to do. You send it as plain RTP to Janus, and Janus will make sure that it's actually WebRTC compliant whenever users are going to request it, and that's basically what the streaming plugin does. And this allows you to basically do the streaming part using this kind of a plugin, and then maybe you allow people to interact with each other using the video room plugin. So, for instance, you want people to talk, you want to watch the soccer match, the football match with your friends at home, then everybody just opens the web page. All of you are getting the same match in the streaming plugin window, and then on the side you see with each other, basically have a sidebar web conference between each other. And then again, you can just do plain contact center or communication within social networks as well, where you involve basically different plugins. So, for instance, the C plugin to be able that you are able to interact with whatever you already have in place, and you did not want to let's say, change for some reason, but then you can also leverage some different plugins in order to just make sure that the WebRTC side of things works. So, for instance, just have an echo test plugin ready just for self-testing, just to make sure that you are able to use WebRTC in the first place without involving the SIP side of things yet. And maybe a record and play plugin just for messaging, just to record the message without involving SIP again, just to say, I tried to call you, maybe try to call me later again, and so on. And these are just a couple of graphical ways to describe pretty much the same thing. This is the webinar kind of approach, and this is how we might, let's say, combine them from an application perspective, so from a user interface perspective. So in this case, for instance, we might have this is me speaking over here. This is my screen being shared. So this is what every person attending the webinar would see. And maybe there's some external component down here that implements, let's say, a chat, a Jabber feed, or a Twitter feed. Anything that you want basically bundled in there, you might do. So it doesn't mean that everything needs to be implemented by Janus, of course. Again, Janus is supposed to be a set of bricks that you can then combine with stuff that is coming from other parties as well. And this is a very simple overview also what I was talking about social TV, where we see, imagine there a soccer match happening, and on the right, you and your friends talking to each other, rejoicing whenever your team scores a goal, and being sad whenever you fail something. Of course, we wanted this to be controllable somehow, and for this we implemented the admin API, which is mostly useful to troubleshoot things that are related to the WebRTC side of things, because this interface that you can enable, which is also JSON-based, that at the moment only request response, but we want to make it asynchronous as well. It basically allows you to control some of the functionality of the stuff, but it's mostly useful for just investigating whatever is happening on the WebRTC end. So if the code didn't work for some reason, maybe you got a black screen or something like this, then maybe you might want to have a look at that just to figure out what went wrong. Maybe the ICE connectivity checks failed, maybe the DTLS handshake failed for some reason, maybe everything worked fine, but then no media is being exchanged for some reason, and so on, and the Janus admin API can help you with that. So after all this introduction, you may be wondering whether or not Janus can actually help on the SIP side of things, and in our opinion, of course, the answer is yes, because this is one of the requirements that we have, because as I was mentioning at the beginning, we are mostly active in the web conferencing world since the beginning, and we have a SIP-based conference bridge basically, and our SIP-based and our audio side of the conferencing part is still SIP-based, which means that this is an important part for us. And not surprisingly enough, we do have a plugin to handle the SIP communication, which you can also try yourself for that web page if you want to give it a try later. And it basically acts as a WebRTC to SIP gateway, which means that, again, on one side you have WebRTC, on the other side you have the plugin acting as a SIP endpoint, so that you have a SIP and either secure SIP or just plain SIP, and either secure RTP or plain RTP on the other end. And as I was saying, the Janus plugin actually acts as a SIP endpoint, and this was done on purpose, which means that all the SIP stack is actually implemented on the server side via the Sophia SIP stack specifically. And which also means that WebRTC users are actually not aware of SIP at all. So the WebRTC users, so whenever you open that web page that I showed up there, you won't see any SIP message at that level. You only see very simplified JSON-based interaction that says, for instance, you've got a call, I want to call this person, and so on. So the only thing that you see are basically just SIP URIs, because of course this still makes sense, of course, also at that level. But in principle, you do not see the SIP complexity at all. It's all handled on the server side. And no transcoding is involved as well. Media is just relayed, which means that if you want actually transcoding, you need to handle it at a different level. In general, we did it like that because we thought it would actually simplify the life for web developers, because of course, not all web developers are actually very familiar with SIP, which is a very complex protocol and a very complex like management in general, which is why we only expose the SIP URIs at that level. We have some basic methods to allow you to start a call, to hang it up, to answer, and things like that, but nothing more than that. We do allow some headers injection for some more specific use cases. So whenever, for instance, you want to send a new invite and you want some headers to be available because they are relevant to your own platform, you can do that, but nothing more than that in principle. Of course, you may or may not want it to be that simple. Again, as you said, the main target for us was mainly us because it made sense for us. We are not really interested in the complexities of handling the SIP part ourselves within the browser, maybe via JSC or CJS or things like that. But you actually may want to do to have more control for some reasons, maybe to reuse, for instance, one of the stacks that I mentioned before. And again, the existing SIP plugin does not allow for that. It only exposes some very limited control over that. I mentioned the custom editors. You can make sure that you send a simple JSON message and this is translated to a SIP info DTMF message on the SIP end. You may choose whether or not to negotiate SIP security and so on, but that's about it. So if you actually want to have more control, you basically need a new plugin, which is why Janus can help in that sense. It doesn't mean that plugin that we have is the only way to do SIP. You can just write a new plugin that maybe is more fit for your own scenario. And Saul's idea, I mean, I had a chat with him some time ago, was something called like boring SDP, which is a plugin that doesn't necessarily involve SIP within the plugin itself, but basically just allows you to do basically just pure media gateway. So you incorporate the SIP part from the media part from Janus itself, which means that you're still then able to handle the SIP transactions yourself and then leave all the media part to Janus itself. This is not a plugin that exists already, but this is something that could be done. This is something that I've been talking to Saul for a while and may see the light in the future. Again, if you do not like Sophia SIP, for instance, you may also implement your own plugin that uses a different SIP library like PJSIP or something else that you're more comfortable with. You're completely free to do whatever you want at the plugin level. So this is just what is available right now and what could be done with it. Another nice idea would actually be, and this is also being discussed, you've seen some presentations about it, is also the interactions with Homer in general. In order to, since we have SIP in Janus as well, it may make sense to also have some statistics and some information about the SIP management within Janus to be made available to whatever instance is actually Homer compliant as well. And I've been talking with Lorenzo and Alexander about this a while during these 2 days, and there may be some easy, more or less easy ways to do that. So this is something that may see the light in the near future, which is really cool. So basically, just allow you to convey via head basically all the kind of information that is actually originated in Janus and then reaches the Homer instance somehow. At this point, you may be wondering if this is actually being used somewhere, or if you've been just talking about, let's say, smoke and mirrors so far. And of course, we use it ourselves for many things because we were mostly interested in this for our own purposes, and then it actually proved useful for a lot of other people at the same time. I mean, we're using it for web conferencing and webinars mostly as a WebRTC to SIP gateway, of course, because as I mentioned, our web conferencing platform is still SIP-based for the audio part. And also for the streaming of live events in general. I quickly mentioned the ITF meetings, and I'll show you a couple of slides about this later, but it's really useful for us because it allows us to broadcast large conferences like these on the WebRTC interface so that people from home can just watch the conference pretty much as you are doing, but from the comfort of their home via WebRTC, so via a browser without having to install anything. But a lot of companies are actually using it in a lot of creative ways, so ranging from, let's say, more traditional applications like e-learning, contact centers, and so on, to also much more complex applications like, again, social TV, TV broadcasting, Internet of Things, deploying these over, let's say, heterogeneous devices like Raspberry Pi, drones, mobile devices, and so on, which is really exciting. There's been a lot of excitement about this, which really made us proud. And the nice thing about this is that this modular approach that we've chosen is also starting to pay off, because people are starting to write their own plugins for both the media manipulation side of things, but also for the transport, or maybe just stuff to actually talk to Janus, or let's say talk to Janus instance from a server in order to control it and have more control over this for several things, maybe from a Node.js application, a .NET application, or whatever, so things like that. And you can see some references about those in the resources link that I put there. And just to conclude, I'll give you a quick overview also of some tools that are actually, some tools made by us and not only, that are actually using Janus at this moment. This is an overview of the ITF director room control application. Basically, if you do not know this, the ITF meets 3 times a year, and they have 8 tracks in parallel where they basically have a lot of sessions every day. So we basically have to control 8 rooms at the same time, 8 physical rooms at the same time, with cameras like this, with a laptop attached to a mixer somewhere and so on. And of course, we cannot be in all rooms at the same place. So we have a WebRTC-based control application that allows us to monitor everything that is happening everywhere, and can also allow us to remotely control the cameras and follow the speaker if it's moving or not, detect issues as soon as they happen, and so on. And of course, the users are also going to use WebRTC at the same time. So what you saw there is the controlling application, and this is what the users actually see when they join an ITF meeting provided by us. And so all those streams that you see there, all those video streams are actually WebRTC based, and what you do not see is the audio part is actually implemented via the SIP plugin, because we handle the audio via SIP in the backend. And all of this can also be recorded so that it can be post-processed later on, let's say, to a YouTube video or something like this. But it's of course more interesting to know what other people are doing with this. And some people are actually doing some crazy things like using Janus as a means to control a drone via a web browser, via WebRTC. And this is an example made by Tim Panton and Neil Stratford, who actually implemented a way to control a parrot drone via a new plugin just implemented for the purpose, which basically allowed them to control via a custom SDK this parrot drone that you see over there via data channels. And then the video originated by the parrot drone was then made available to Janus as well and provided back to the WebRTC user. And something similar has been done also by the Matrix guys, who also used it to control a flying drone this time. And they also won a prize thanks to this demo that they made, where we actually interacted with Janus and their Matrix infrastructure. I think last year in Miami, and they also had some videos showing you how this drone was flying around and how they were capturing the video back. There's this nice tool called Hangouts, which stands for Janus Hangouts, made by the OpenSIPS team developers. They basically wanted to implement some sort of Google Hangouts clone, but completely based on Janus, which means that the only infrastructure that is there is actually Janus itself. So they are using it, of course, for the audio and video part, but also for the chat using data channels and so on. So we just implement all the web-based stuff, and all the server-side stuff is handled by Janus itself, which was really cool. There's Silk Server, which is one of the applications that Saul and Adrian have worked on in AG projects lately. They are also using Janus as the WebRTC gateway to interact with their own SIP server-side infrastructure. And I like that feature in particular because that's the first time that I think Saul got it working. And this is more recent news. I think you all know about Slack, and it turned out that Slack is actually using Janus in its own infrastructure to have WebRTC functionality for the teams cooperating with each other. This is not something that I could test for myself because it's only available for premium users as far as I know, but if you look at those two blog posts over there, which again come from WebRTC Axe, which is a very popular blog for WebRTC developers, you'll see that there are two different people that analyzed the traffic and found out the fingerprint basically that were being used in the WebRTC communications were exactly coming from a Janus-based infrastructure, which is kind of cool. I wish they gave us money for that, they didn't, but it's still nice to know that such a large company with such a large deployment as Slack is actually using Janus, because it means it's probably useful also in very large deployments, which is comforting to know, especially for us. There's this e-learning platform by Lenovo, which is called AirClass, which was announced recently. They are also using different plugins, including the SIP plugin for this part. And they basically allow you to do an online lesson, an online e-learning lesson based on WebRTC thanks to Janus. There's these couple of tools called like Squiggle and Speak.io, basically by the same people that allow you to do team co-working pretty much as Slack. And they also implemented all the audio-video functionality thanks to Janus. And finally, there's this tool called Beading, which is a business conferencing application made by this Swiss company called Beading, which also implements different interactions using different plugins, video rooms, plugin and things like that, to allow you to do web conferencing on the web and so on. This is not a complete list. This is just a limited list of people that I asked permission for in order to talk about things that we've been doing so far. And they were nice enough to do that, but there are of course other companies and people that are using this that prefer not to be, let's say, disclosed at the moment. And in principle, there are some things that we still need to do. I mean, Janus is an ongoing process. It's still young, but we've been doing a lot of things and we want to do other things. Some of these being support for an effective renegotiation, handle multi-stream in general, which is something that for WebRTC is important, but more in general, fix and improve things in general, and for this you can help us a lot, because in general what I want to do is make Janus, let's say, known to as more people as possible, so that people can play with it, write new applications, using Janus, writing new wrappers, plugins and so on. Just play with it and let us know if there's anything that is required. And if you want to meet us again, I mean, we've been to a lot of places in the last month, and I've just come back from San Francisco where I won this prize thanks to Janus, which was cool. And next week I'll be in Berlin for the Camarillo World, and then I'll be again in Berlin for the ITF, as you mentioned, because we are streaming there, and I see the chair there waiting for me to complete. So I don't know if there's any time for questions and so on, otherwise
There is not, unfortunately.
sorry about that.
That's okay.
Anyway, if you want to talk about it, I'll be around for some more long discussions. Just let me know.